Hello, and thanks for clicking on this next Prenorculus production. Today, we are going to review all of the ways that you have learned how to factor in Algebra 1 and Algebra 2, all in this one video. So we're going to review them all. If you have additional questions, you should see your teacher or perhaps refer to some other videos online because this is going to be your review of all the methods of factoring. All right, so let's get started. The first method of factoring we're going to review is how to factor a greatest common factor, or GCF for short. So remember, greatest common factor means it's the largest. In this case, the first case here, we're going to look at our three numeric values, 3, 12, and negative 18, and we're going to take out the largest number that we can, the biggest factor that goes into all three. And in this case, it would be 3. 3 goes into itself, it goes into 12, and it goes into negative 18. So I'm going to take 3 out. I could also try to take one of the variables out. However, the first term has x squared in it, the second term has x, and the third term does not have a variable, so I cannot factor out any variables. So all I can factor out as a GCF is 3, and then I'm going to write what remains of this polynomial in the parentheses. So to do that, if you remember, you're just dividing by whatever you took out as the GCF. So 3x squared divided by 3 is x squared. 12x divided by 3 is a positive 4x. And negative 18 divided by 3 is negative 6. So this has been factored correctly and completely. We cannot factor it anymore. So that is our answer. And remember, the most important thing you need to remember about factoring is that factoring undoes the distributive property. So if you distribute the 3 back into the parentheses here, you should get back to where you started, back up here. If you don't, then what you've written as your factors is wrong. There's nothing to say about it. It's incorrect. Okay, and you have to go back and try to fix it. All right, let's look at the next one real quick. We have negative 4x cubed plus 8x squared minus 20x. So one of the rules of factoring is that you do not lead with a negative. So if your polynomial has a negative as its leading coefficient, you have to take the negative out as part of the GCF. And then we have a 4, an 8, and a negative 20. So 4 is in common in all three. So I'm going to take out negative 4. And then I have an x cubed in my first term, an x squared in my second, and an x in my third. All three of these contain at least 1 power of x. Some of them have more than 1 power, but they all have at least 1 power of x. So I'm going to take out 1 power of x as part of my GCF. So my GCF here is going to be negative 4x, and then I'm going to divide all three of these terms by negative 4x to decide what belongs in the parentheses. So negative 4x cubed divided by negative 4x is x squared. 8x squared over negative 4x is a negative 2x, and negative 20x over negative 4x is positive 5. And that is my answer. I'm done. I factored the GCF out. What's inside here, x squared minus 2x plus 5, will not factor. You may already remember that, but if you don't, there's going to be a review of this method inside here coming up in just a moment. But that would be our correct answer. This is all done. All right, so let's go on to the next method. The next method is factoring by grouping. You know it's a factoring by grouping problem if there are 4 terms. Okay, that is your key. Here is the way that grouping works. You group the first 2 terms together in a set of parentheses. You group the last 2 terms together in its own set of parentheses. And now you're going to factor out the GCF from each set of parentheses separately from one another. So if we look, our first terms, or first set of parentheses is a 2x cubed minus 4x squared. The GCF is 2x squared. And then we're going to write what remains in the parentheses here. So we'll divide by 2x squared, and we'd have x minus 2. Our next set of parentheses, this plus sign that's in the middle gets brought down. It's going to be part of the GCF, okay, in our second set of parentheses, no matter what. We see a 7x and a 14. 7 goes into both. The third term here has an x, but the last term does not have an x, so I can't take an x out as part of the GCF. All I can do is divide both of these terms by positive 7. So positive 7x divided by 7 is x. Negative 14 divided by 7 is negative 2. So now what you should have is you should have two GCFs that you factored out, my 2x squared and my positive 7. And then you should have now a set of parentheses that match. The x minus 2's are exactly the same. So now they are a GCF. Okay, they are a GCF between this term and that term. The x minus 2's are what's in common. So I can take out an x minus 2. And I'd be left with, if I do that, the two GCFs, the 2x squared and the positive 7. So I'd write 2x squared plus 7. And this is now completely factored. This is the correct answer. Okay? This is the correct answer. All right? All right, let's try the next one. Again, it has 4 terms, so this is a grouping problem. I'm going to group my first 2 terms together. I'm going to group my last 2 terms together. So my first 2 terms, the GCF, there's no GCF between 6 and 5 other than 1. The last, but there's an x squared and an x, so I can take an x out of there. Oops. And then I'd be left with 6x plus 5. So now bring down your minus sign. That's going to be part of your GCF. And I look, I have a 6x and a minus 5. So there's really nothing in common, but I do have to write a GCF to factor by grouping. So I'm going to say that 1 is in common. Now that 1 happens to be a negative 1 because of that sign that's there. So I'm going to divide both of these by negative 1. And I have a negative 6x divided by negative 1, which makes 6x. And then I have a negative 5 divided by negative 1, which is positive 5. And now if I look at my 2 terms here and here, there's a GCF. That GCF is 6x plus 5. It's in common in both. There it is. So I'm going to factor out the 6x plus 5. And if I were to divide that out on this term and this term, since it's a GCF, I'd be left with x minus 1. And now this is factored completely. And that's the correct answer. Okay? Again, if I were to FOIL or double distribute the 6x plus 5 times x minus 1, I should get back to here. If I don't get back to this, then this is wrong. There's no other way to put it. Okay? So you can check to make sure that you factored correctly. All right, let's go on to look at trinomials. Trinomials have 3 terms. Okay? We're going to look at 2 methods to factor trinomials. One is a fast method called 1 a.m., and then the other method takes a little while. It's called AC. We'll explain the difference real quick and remind you. Now remember, 1 a.m., which some teachers teach it as, means that there's a 1 in front of the x squared. There it is. Okay? 1 is my leading coefficient. And then I'll put an a and an m here, which means that I'm looking for 2 numbers, and they have to do a couple of things. They have to multiply together to equal negative 12, and they have to add together to equal negative 4. So I need 2 of the same numbers to do both. They have to multiply to negative 12 and add to negative 4, and I'm sure you can figure out very quickly that the 2 numbers are negative 6 and 2. So now we can pattern factor this. I call it pattern factoring. Pattern factoring for 1 a.m. is you lead with an x and an x because the first term here is x squared. So x times x would give me that x squared. And then I'm going to fill the rest in with my numbers. Minus 6 plus 2. And that's the correct answer. X minus 6 times x plus 2. It's factored. Okay, now let's come over here to this problem. What happens, of course, If there's not a 1 in front of the x squared, well, then you have to use a different method. Some teachers use slide and divide. I use the AC method. You could also do guess and check. Any one of the three are valid as long as they're done properly. So I'm going to show you how the AC method works, or remind you how it works real quick. The AC method involves you multiplying the A and the C. So the two numbers that I find have to multiply to be negative 18. 3 times negative 6. They're going to have to add together to be the middle term, which is 7. So those two numbers that I'm looking for are 9 and negative 2. Those two numbers both multiply to be negative 18 and add to be 7. Now, I can't pattern factor this like I did over here, but what I'm going to do to factor with the AC method is I'm going to bring down the 3x squared. I'm going to take the middle term, the positive 7x, and I'm going to split it up using the two numbers that I found. I'm going to call positive 7x positive 9x minus 2x, which I could do because 9x minus 2x is 7x. There it is. And then I'm going to bring down the negative 6. Now I have 4 terms. And what do I do with 4 terms? I group it. So I'm going to do the same thing I did on the last slide. I'm going to group the first 2 terms together. I'm going to group the last 2 terms together. There they are. And I'm going to try to find GCFs. The GCF between 3x squared and 9x is 3x. I'd be left with x plus 3 in the first set of parentheses. My next GCF, bring down the minus, between 2x minus 6 is 2, so it's a negative 2. If I take out negative 2, I'd be left with x plus 3. Now, I have 2 more terms. 1 term, 2 terms. There's a GCF. There it is, x plus 3. It's in common in both. So I'm going to take out my x plus 3. And if I divide both of these terms by the x plus 3 that I took out, I'm going to be left with, in the parentheses, 3x minus 2. And that has been factored correctly using the AC method. So the AC method is one way you can do this. You can guess and check if you know how to do it by guess and check. If you know how to do slide and divide, you can do slide and divide. It does not matter to me which method you use, as long as you can use that method correctly to factor as the correct answer. That's what I care about. All right, moving on. Let's talk about the difference of 2 squares. Difference of 2 squares. You'll need 2 terms for this and a difference in between. Super important. Difference meaning subtraction. Okay, and I have 2 things. So I'm starting here with x squared, a minus 25. That's good. There's 2 terms. There's subtraction in the middle. Super important. And I should be able to take the square root of each one of these pretty easily. So the square root of x squared would just be x in this case. The square root of 25 would be 5. So now I can pattern factor this again. So I'm going to have 2 sets of parentheses. Here are my 2 values, the x and the 5. So I'm going to write x minus 5 with pattern factoring times x plus 5. And that's the correct answer. This is factored. Okay, if I were to FOIL or double distribute x minus 5 times x plus 5, I would get x squared minus 25. All right, let's try another one. Here we go. We have 4x squared minus 49y squared. Again, 2 terms. There's subtraction in the middle. If I were to take the square root of 4x squared, it would give me 2x. The square root of 49y squared would give me 7y. So I can pattern factor this. 2 sets of parentheses, multiplication in the middle. So I'm going to factor this as 2x minus 7y times 2x plus 7y. And that's the correct answer. This is done. There's no more to do. Okay? It is important that whatever term was here, the 4x squared, the square root of it was 2x, that the 2x does have to come first in each set of parentheses because of this subtraction in the one set of parentheses. It does have to lead. Whatever leads here has to lead in the parentheses as well. Okay, all right, let's go on to our last method. Oh, no, we have one more, higher power factoring for our x to the fourth minus 6x squared plus 8. Okay, this is higher power factoring. This is actually the same factoring method as something like this, x squared minus 6x plus 8. We know how to factor this as already. This is a 1am factoring. It's a trinomial. There's a 1 in front of the x squared. I'd have to find two numbers that multiply to be 8 and add up to -6. Those two numbers would be -4 and -2. So I could factor this problem as x minus 4 times x minus 2. And that would be the correct answer for x squared minus 6x plus 8. But this doesn't say that. It says x to the fourth minus 6x squared plus 8. It's similar, but not certainly the same. So, but it can be done the same way. This is still a 1am problem. It's a trinomial. I could still do it by 1am. I'd have to find the two numbers that multiply to be 8 and add to be -6. They're the same two numbers. It's -4 and -2. But here's the thing. When I write my pattern, okay, and I'm going to have my two sets of parentheses, I can't put x and x here because x times x, if I were to try to FOIL it back again, would only give me x squared. So I need x squared and x squared there so that I would get x to the fourth. And that's why the middle term is -6x squared. So when I write -4 there and -2 there, if I were to do x squared times the -2, I'd get -2x squared. -4 times x squared would be -6x squared, or -4x squared, and combine them, I'd get -6x squared. Okay, so I'd have to lead with x squared and x squared for this x to the fourth, rather than x and x, which I could lead with for those x squareds. All right, now, the problem is this isn't complete because x squared minus 4 will factor again, right? It's the difference of two squares. So it will factor as x minus 2 times x plus 2. And then I'll bring down the x squared minus 2, since that's not the difference of two squares. 2 is not, if I take the square root of 2, I get 1.41. So we're not going to do square roots with difference of two squares. And I would say that this has been factored completely. We are looking for the answer that's been factored completely. Okay? And that's my correct answer. All right, finally, let's go and factor cubics. So to factor cubics, these are the two formulas that you would have to know. You need to know them off the top of your head. Okay? To factor a cubic means you're going to write each term, okay, as something that's being cubed. So for example, if I want you to factor x cubed minus 27, well, x cubed is just x being cubed. Okay? And then 27 is 3 cubed, right? 3 times 3 times 3 is 27. All right, so now, to use these formulas, I have to write my polynomial in this way first, and then I can use the formula, because now I know that my a is equal to x, and my b is equal to 3. So now I'm going to try to factor using this top formula here, because this is a cubed minus b cubed. And that's what we have here, x cubed minus 3 cubed. So we're going to fill in a is x and b is 3 into this formula. That's right there. So we are going to write. So let me write the formula here. It's a minus b times a squared plus ab plus b squared. Okay, so we're going to fill in the number, or the values. We have x minus 3 times x squared plus, I could write x3. I don't like that. I'm going to write 3x instead, plus 3 squared. And 3 squared is just 9. So I have x minus 3 times x squared plus 3x plus 9. And that is the correct answer. This has been factored correctly. If you factor correctly a cubic, what's left here in the second set of parentheses will not be able to factor anymore. You won't be able to have to factor it, or you won't have to look or try 1 a.m. It won't be factorable, okay, provided you do it correctly. All right, let's look over at this one. We have 8x cubed plus 1. So that's going to point me to this bottom formula this time, right? A cubed plus b cubed. But we have to figure out what's being cubed. Well, to make 8x cubed, I'd have to take 2x and cube it, right? 2x times 2x times 2x will give me 8x cubed. Plus, well, to make 1, I just cube 1. 1 cubed is 1. So that means my A must be 2x, my B must be 1, and now I'm going to apply this bottom formula. It says A plus B times A squared minus AB plus B squared. Here we go. So I'm going to plug them in. We have 2x plus 1 times 2x, quantity squared, minus 2x times 1 is just 2x, plus 1 squared. So if we clean that up a little bit, we have 2x times 2x, that's 4x squared, minus 2x plus 1. And this is now factored. We won't be able to factor the 4x squared minus 2x plus 1 with AC or slide and divide. We won't be able to find any numbers that make it work. Okay? As long as you apply these formulas correctly, like I said, this second set here won't be factorable anymore. You won't have to worry about it. All right? And that is your review, fast review of factoring. All the different methods that you've learned before. Okay? Thanks for clicking.